All right. So not a lot different than any of the other assignments that you've done for me in this class. Okay. There's going to be some problems on here that are basically like the ones we've done in class. All right. There are a couple that are going to make you think outside the box. And I usually throw one or two on an assignment that make you think outside the box a little bit. Okay. So same as always, make sure you look at the point values so you know about how much work should be done for these. Okay. And don't overthink some of them because some of them are quite simple. All right. Like, the period of a simple pendulum is to be 2 seconds. What should be its length? I mean, we know what the formula for pendulum is, okay? So we can do that one easily. All right, number 2 is also a pendulum question, but it's comparing 2 different grandfather clocks, okay? Just so you know, a pendulum in an old grandfather clock didn't just swing back and forth because of gravity, all right? They were actually adjusted. They had springs in them that kept them swinging over the course of a day because a pendulum would only swing for a few minutes before it would stop. Okay, so they'd have to be spring loaded so that they would keep going. But in order to take it from a place where the acceleration due to gravity changes, you have to change the length of the pendulum. In other words, you have to change its pivot point. Right? Otherwise, it will not keep accurate time because the acceleration due to gravity will change its period and it won't click the gears at the proper rate. Okay, so it would need to have its length adjusted if you were moving it from one place to another where there was a significant change in the acceleration due to gravity. All right. For number 3, okay, another pendulum question. So you got 3 pendulum questions. Actually, you got 4 pendulum questions in a row. Okay, number 4 is also about a pendulum, okay, which is just a wrecking ball. In this case, it's just swinging back and forth. All right, but you are comparing one pendulum to another. There's a ratio thing going on in this question. Okay, so read it carefully. You have a small pendulum that's going back and forth, right? We are looking for the length of the wrecking ball. All right, so they're telling you that the small pendulum you have made goes back and forth 5 times. I think it says 5 times, right? Makes, yeah, 5 cycles. Okay, so the small one makes 5 cycles in the time it takes the wrecking ball to make 1 cycle. So there may be something about the small pendulum you can find out and then apply to the large pendulum. Okay. All right, number 5, also pendulum question. Okay. We know it has a certain length. Okay, we want to find its period. We want to find out how long it will have to be to double its period. Okay, and why is this number not just double the length? Little explanation there. Okay, a couple of sentences explaining why. Okay, number 6, also still a pendulum question. Okay, oscillating on the moon this time. The moon's gravity is 1/6 of Earth. Okay, this is not a measured value. Thus, it does not affect your significant figures. All right, so the 1/6 does not affect your significant figures. Okay, keep that in mind when you're calculating the acceleration due to gravity there. All right, number 7, we have our first spring question, mass on the spring. Now, the thing you need to know here is that this situation needs to be read very, very carefully. Okay, in the first situation, one mass is hung on this spring. Okay, and then it's pushed and it's allowed to oscillate up and down, right? When it does that, its frequency is 10 hertz, right? When another object of mass 2 is hung on the spring along with the first mass, so both masses are on in the second situation, the frequency is 5 hertz. Find the ratio between the 2 masses. So I'm going to give you a big, big hint here. You don't need to know what the real masses are to do this question. Okay? It only wants to know the ratio between the masses, and you actually don't need real masses to calculate that. So you could possibly use any representative number you wanted in this question for certain values. Okay? They also don't tell you what K is, okay, in this question, but it is the same spring both times, right? Since it's the same spring, it's the same both times. Maybe you can pick a representative number for that too. Okay, you're only trying to find the ratio here. You don't actually need real masses in the end. Okay, it's a tricky question. That's the think outside the box question. Okay, question number 8. Okay, we have a spring with a constant of 1,526 newtons per meter, oscillating with a frequency of 3 hertz. Notice that in most of these questions, I've given you frequency, not period. Remember, you do have to make that switch before you start doing much. Okay, What mass is suspended from it? So just a simple mass spring question. Okay, number 9, we have a spring mounted on the floor, oriented vertically. So in other words, it's set on the floor and it's going to oscillate like this, up and down. Okay, from the floor. All right. A 6-kilogram block is placed on top of that spring, pushed down, started oscillating. Find the frequency of the motion. All right, number 10, we have a bungee jumper. That's also a mass on a spring. After taking the leap, the jumper oscillates with simple harmonic motion over 30 seconds. She oscillates 5 times. All right, you may be able to find some important information with those 2 numbers. Okay, we know the spring constant of the cord. We're looking for the mass of the jumper. Okay, and then for number 11, okay, we're starting to talk about maximum speed, and number 12 talks about energy. Okay, number 13 also talks about energy. All right, but look, sorry, your point values are different. I think these are both out of 3 on yours, right? They are. They should not be out of 6 there. Okay, these point values are different on yours. Okay, keep that in mind when you're doing them. They're quite a bit simpler, okay, than the question may lead you to believe. All right, but the last few are energy questions. They may not necessarily be conservation of energy questions. They may just be energy questions. All right, questions on those? All right, I will have a due date for that as well as your West Ed assignment, which I'm photocopying right now and will grab for you, okay, and give those to you today as well. Okay. All right. If there are questions while you're working, I will give you whatever small cryptic hints I can. Okay. But otherwise, let's get as much of that done as we can in class today. We should be able to get a lot of it done because many of the questions are quite simple. Okay.